going to be a video about the molecular orbitals. This is something can get really confusing, so let's just break this down for you. Molecular orbitals, this is where it's the region of space for the electrons. So at this point, you should not think about the electrons as in moving in this sort of orbit like a solar system. From the quantum model, electrons are just found in somewhere in this three-dimensional space that Schrodinger used with his sign equation. So in his equation, he calculated the probability, like where exactly will the electrons be found. And once you have the probability, basically you just figure out, oh, I think the electron could be here, 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 here. And eventually, if you look at all the probabilities of where the electrons are found, you get this sort of cloud or this sort of shape. That's where the molecular orbital is. So in molecular orbital, you can see that there are different shapes that comes with it. So the first one is your S sublevel, and it has this shape. And then if you go down to the next one, you have your P, and it's in this little dumbbell shape. That's your P sublevel. And then once you move on to the higher sort of energy levels, you have your D, and D has 5 different separate individual molecular orbitals. And then in the next one, in the F energy level or sublevel, it has 7 different ones. So one thing to know that each of these molecular orbitals can hold a maximum of 2 electrons. So in S sublevel, it only has this shape, so it only can hold 2 electrons. However, as we go down in P sublevel, you can see that there are 3 individual orbitals for each of them. So that's basically 2 plus 2 plus 2, giving you 6 electrons in the P sublevel. And then once we go down to the D one, you can see that there's 2 in each of them. So that's 2 plus 2 plus 2 plus 2. That's 10 electrons in the D sublevel. And then you can see that for the F sublevel, that's 14 electrons. So when you look at this one, it actually makes sense, because if you look at the periodic table, when you look across, that's how many electrons you have. So let's moving on to the next 3 things. Oh, this energy one is sort of cut off. Let's see if I can move it over. Energy level. And so 3 things. Energy sublevel, this tells you the size. This is how big that region of space is. So whenever you talk about molecular orbitals, or in the future about electron configuration, you're just basically looking at how you're building your atom, like from Lego blocks, building it bigger and bigger. So obviously, the bigger it is, the bigger has higher energy level and more electrons. So when you see this quantum number n, this is where you see n is equal to 1, n is equal to 2, n is equal to 3. This is where you have your energy level, which tells you the size, how big that cloud is. Whereas in sublevel, this will tell you the shape. So this will tell you if it's the S shape, the P shape, or the D or the F shape. This is all sublevel. And in orbitals, these are your individual orbitals. That's where you have your individual sphere for the S. For P, it has your 3 different orientations. And then for D, you have your 5. I can't even draw the 5. And then F, you would have your 7. So your energy level N, L, and M, that's what they will tell you. So if you look at this one, principal quantum number, that's your N is equal to 1, 2, 3, and etc. This gives you the size, and that's how you determine the size if you're going down the periodic table. The next one is the angular quantum number. That's like your sublevel. That's your L. That tells you the shape. Basically, this is the S shape. This is the P shapes, and then this is the D shapes, and then etc. for the F one. And the magnetic quantum number tells you the spin. So in Pauli's exclusion rule, basically, in order to have 2 electrons found in the same sort of region of space, the spins of the electrons has to be opposite in order for them to exist together. So that's your magnetic quantum number. So here's a question for you. How many total orbitals are there in energy level 1? So since you have energy level, level 3. So in energy level 3, you have 3s2, 3p6, and 3d10. Since this question is just asking about level 3, you don't care about level 1 or 2, so you're just looking at 3. So in S2, there's one s orbital, In P, there's 3 orbitals. And in D, there are 5 orbitals. So that's the total of 9 complete orbitals, right? 1 plus 3 plus 5, that's 9. So how many electrons will be found in level 3? Well, in level 3, then you will look at how many orbitals you have. And since you have 2 electrons in each of them, you have a total of 18 total electrons just in level 3. Okay, so this is just in level 3, not the total amount of electrons for the atom. So hopefully this tutorial has sort of helped you understand what molecular orbital is based on the electron cloud, how to build up the atom, knowing the difference between your energy level, sublevel, and molecular orbitals, and understanding how to calculate the number of electrons. So hopefully this has helped you. Okay, see you later.